What's up guys, this is Youngno. Let's solve this question. The length of a rectangle, so we have a rectangle, so let me just draw an arbitrary rectangle. And this is length, and this is width. And the length of a rectangle is longer than its width by 39 inches. So that means our length has to be equal to W plus 39. So far so good. If the area of the rectangle is 126 square inches, that means area of the rectangle can be found by make a product of length and width. So L times W has to be equal to 126. And we're looking for the length part. L equals what? So take a look at here. We have two variables and two equations. That means that system can be solved like algebraically or graphically. Let me show you how to solve this system with Desmos. You're allowed to use Desmos all the times when you're taking digital SAT. So let me just put up a Desmos here. Okay, let L represent the Y, and I'm just gonna plug in the first equation. L, which is Y, equals X, which is W, plus 39 here. And L is our Y, times X is our W, and that has to be equal to 126. So we have graph of two equations, and obviously we have two intersecting points. But take a look at here. This intersecting point, it has negative X coordinate and negative Y coordinate. That means our length and width values have to be negative values. That does not make sense. So let's go on to the other intersecting point over there. So that has to be the solution to the system, the solution we're looking for. So its X coordinate is 3. Our X was W, but the thing is we're looking for L value, which is our Y value. That has to be 42, since the Y coordinate of that intersecting point is 42. So the answer is simply 42. That has to be answer. For those of you who are really interested in solving this system algebraically, let me just show you. But you just could have solved this system with Desmos. When you're trying to solve system, the most common way to do it is substitution. Sometimes you might want to do the elimination by addition, but since here I have a non-linear system, elimination by addition might not work. So let's do the substitution method. So since we're looking for L value, we might want to get rid of W. So let me just pick the first equation and isolate W. W equals L minus 39. So I'm just gonna substitute W with L minus 39. Then what you have here is an equation with only one variable, L. I substituted W with some expression in terms of L just because we're looking for L. So this is just simple quadratic equation. L squared minus 39L minus 126 equals 0. So once you solve this equation, you can get the correct answer. This is factorable. But the thing is, we already know that the correct answer is 42. So you might want to factor 126 out with 42 and 3. And if you put negative sign in front of 42, that expression can be factored out as L minus 42 times L plus 3. So that will make 42 and negative 3 as the potential solution to the given equation. But since length cannot be negative value, positive 42 has to be answer. But take a look at it. Once you're trying to solve the system algebraically, you have a quadratic equation, but that constant is too big. So you might get confused and you might take a mistake when you're trying to factor it out. So what I'm trying to say here is, whenever you have a system of two equations, just use Desmos and solve it graphically. We're done. See you on the next question.